Hi guys, today I'm going to show you how to construct a transfer lining in MATLAB for image classification and object detection. So transfer lining is nothing but modify the structure or layer of the deep neural network which is already designed by someone. Here you can see the structure of the transfer lining or reuse pre-trained network. First of all, we have to load the pre-trained network, then we have to modify the layers or replace some layers, then again we have to train our network, then predict the network and deploy the result. So the transfer lining is nothing but we need to load any one of the pre-trained network, then we can change or modify the layers, then we can transfer it for our requirements. So based upon our requirements we can change or modify the layers of the pre-trained network, then we can develop a new neural network. That is the best use of the transfer lining. This is called the transfer neural network or transfer lining neural network. So go to MATLAB tab, then put the initial command clc clear all, close all, then go to the desktop, create one folder, then rename as deep transfer. So we all know that if you want to construct any neural network means we need to have some training data. Today what type of data I am going to take for training means today I am going to take some leaf data. Copy and paste it here. You can find different types or different kind of leaves. So I'm taking 5 different classes of leaves, leaf type 1, 2, 3, 4, 5. So in this data set only I'm going to classify based upon transfer lining. So after that, which type of pre-trained network I am going to use means alexnet. Today I am going to use the alexnet as a pre-trained network. So before that, first we need to set our path, MATLAB path is equal to, go here and copy, then read the files, full file of MATLAB paths, comma data set. This is the path of data set. Then we have to train our data. So in order to train our data we have to take the image data store, image data store of data comma include subfolders comma true label source comma folder names, label source we are taking the label source as the name of the folder, then count the labels, all the labels, train dot count each label, okay. Now we have set the dataset path and reading the dataset images. Then we have to load the pre-trained networks. load network. Here I am loading the alexnet for our transfer learning. So alexnet. So after that, just save. Save the file to deep transfer as transfer. Then if you run the program, change folder, image data store, store, include UDE, so it's getting busy. Actually it is loading the pre-trained network, that is alexnet. Yeah, it loaded. So pre-trained network, that is alexnet, is already loaded. You can see here. So if you type the net in command window, then enter means you can see the number of layers. Number of layers in the pre-trained network is 25. Then if you put net dot layers means you can see the all the 25 layers. So as we all know that deep neural network consists of the convolution layer, relief layer and pooling layer, everything combined, and they have designed one layer, that is the alexnet. Now we are seeing that 25 layers of the alexnet. So this neural network only, this new deep neural network only we are going to use for our new neural network as a transfer learning. So then if you take the first layer only, means net dot layers of 1 means you can only see the first layer, that is then the image input layer. If you give it as 2 means you can see the second layer, that is convolution 2D layer. If you put it as n means you can see the last layer, that is the classification output layer. Classification output. So now we have loaded the pre-trained networks. Now we have to design the layers. Layers equal to, so the first layer we have to give the first layer, because the first layer is the image input layer. Image input layer. So we only know the size of the image, so that we have to provide the input layer. So I am either 480, 643. So image input layer is nothing but first layer of the deep neural network. So 480 and 640 and 3 is the row value, column value, and the number of colors of the image. Then we have to provide, we need to include the pre-trained network, that is 2:n-3. So 2 means first layer, we have already given the first layer, so we have to start with 2:n-3. Finally, why we are putting here n-3 means net dot layers. If you see the all layers means up to 22, that is dropout. Up to 23 layers we can taken for our neural network. After that, fully connected layer and softmax layer and classification layer. Fully connected layer, they were used 1000 fully connected layers. Why they are taking 1000 means they are going to classify the images in 1000 classes. So we are going to classify the images in 5 different classes, as you see earlier, like leaf type 1, 2, 3, 4, 5. so we have to replace this layer also. So that is fully connected layer of 5. After that, softmax layer. After that, classification layer. So from the 2 to n-3, it is came from the pre-trained network. After the fully connected layer and the softmax layer and the classification layer, we changed this for our requirements. Classification softmax layer, classification layer. Okay, now we have constructed the layers. Let's check it whether it's right or wrong. Just run the program. Yeah, image image input. First I is the small letter. Image input layer L is the capital letter. Then fully connected LAY or fully connected C is the capital letter. CONNECTED. Oh, lot of mistake is there, sorry. Yeah, now we are getting our layers. Image fully connected softmax classification. Okay, then we need to train our network based upon this layer. So first layer is our layer. From second layer to n-3 layers is from the pre-trained network. Then fully connected layer is our layers. We are going to classify the 5 classes. That is why we are putting here it as 5 and softmax layer and classification. Then we have to train our network. Training. We have to first give the training option. OPTION option of gradient steepest method SGDM max epochs EPOS 5 initial landing rate initial LAN RAT 0.001 initial land rate. Okay, now we have provided the training option. Then we need to train it. So training is equal to train network of training data. We are taking as a variable as train TRAN layers YRS layers option. So we have written the code for training also. So let's run it whether it's working or not. Yeah, training option is error giving TRANAG options. This is there. Yeah, it's going well. Yeah, it's training. Yeah, finally we'll get the minimum patch accuracy is 100. So we are getting the 100% accuracy for training. So its training is completed. Now we want to go for testing our images. Testing. So in order to testing, before that we need to test our images. So we have to collect some images from databases. Then I'm taking it from class 4. Then I'm taking it from class 5, 93 and 94. Then just paste it here outside of the photo. Then take on variable a is equal to im read of 21.jpg. Then we are going to classify. Out is equal to classify of training data comma our data. So then figure comma showing our input im show of a, then title string of out. So if you run the program, now it's reading all the database images, then showing the layers, then it's going for training. Then yeah, testing is completed. We can find the type of the leaf, that is leaf type 3. So if you want to show in the form of message box, means message box of string of out. Now I am going the input as 93. 93 I have taken from class 5. So again if you run means training is going on. Yeah, leaf type 5. So it belongs to 5th class, that is leaf type 5. If I give the 94 means, again if you are running means this is also belongs to type 5. So let's check it. Yeah, this is also came from leaf type 5 only. So like that we can classify our images based upon transfer learning. So again I'm repeating, just I'm taking some data sets, then loading pre-trained network, then modifying some layers, and we are converting based upon our required deep neural network. Then we are training the neural network, then checking or classifying our neural network or testing our neural network. Finally we are getting the result. So like that we can do it for other applications or other classes or other images also. I hope you understand everything. If any doubt means you can contact me, and you can comment here also. We are providing and paid and free support for all the engineering projects and other common related projects. Anyway, thanks for watching. I will update the next video in terms of deep learning and how to provide the ground truth labeling for dataset images. Okay, thanks for watching. This is our contacts. If anything means you can contact us. Thank you. Thanks for watching.